Okay, a couple more examples along the line of our trial factor method. You'll note that I have my answers from the previous slide. Hopefully you got the same answers that I did, although you may have noticed that it might have gotten a little bit more complicated with B. We're going to talk about another method for that in a minute, but let's just talk about these ones right here. In this case, I've got the factoring 10 minus x minus 3x squared, and I have to wonder, well, how am I going to factor this guy when I've got just some weird things happening right here? First of all, the x squared term is in first. Well, again, it should not matter. We're going to get two binomial factors. We always get two binomial factors, hopefully, if we can factor our trinomial. In this case, we can. The only difference is going to be that for our leading term, we're not going to have x. For our constant term at the end, in its place, we're going to have x. So we're going to take, let's see, 10. We need factors of 10. And we're going to need factors of -3 this time. This time, right, we do want to make sure that we're paying attention to the signs. Now, what are our choices? Well, again, 10 and 1. We could use 5 and 2. Those seem to be our choices there for this one. That's only 2. That's luckily, it's a minimal number of choices to make. How about -3? Well, we could either say -3 and +1, or we could say +3 and -1. What we need specifically, though, is a combination that when we put them together is going to give us -1x as the middle term. So what could we do? Well, we know that if we take 10 times 1 and 1 times -3, no good, because that's going to have a difference of 7. 10 times 3 and 1 times 1 won't work either, because that's like 30 and 1, and that's not even anywhere close to 1x. So I think that we can get rid of this first combination. Let's look at the second one. How about that? Well, 5 times 3 I know is 15, and 2 times 1 is 2. 15 and 2 has a difference of 13. Not much help. But 2 times 3 is 6, and 5 times 1 is 5. And when we add 6 and -5, we do get +1. Or if we add -6 and +5, we get -1. And that's what we seem to want. So it looks like we should be taking some combination here of 5 and 2, along with -3 and +1. So let's try it out. We're going to have 5 and 2 from our term 10. Right? So this is the first terms. Last terms, well, we need two factors containing x. We want to make sure that we're taking 5 times 1x. So let's make that plus 1x over here. And how about over here? 5 minus 3x. Now, does that work? Well, we're going to have to check our inner and outer terms. When we take -3x times +2, that's -6x. So far, so good. And then we take 5 times +x, we're going to get plus 5x. And when we check those two middle terms by addition, we get -1x. And that is our middle term right here. So it appears that this is our factorization, 5 minus 3x times 2 plus x. All right, how about this next one? Well, that looks just way too complicated for me. Well, one thing that we should do before we do any other factorization, of course, is that we should look for any common factors. And there is a greatest common factor among all of these three terms. Do you see it? Yeah, definitely. It looks like there is a 6 contained in each of these. As a matter of fact, I'm going to go ahead and I'm going to say -6, because I can factor out -6 from each of these terms, just changes their signs. And it looks like you can factor out x from each one of these. So what happens? Well, this is the same thing as saying -6x times, let's see, this is going to be 2x squared as our leading term, plus, because we're going to take a negative times a positive to get 3x for our middle term. And -6x times -5 would give me positive 30x. So my actual factorization that I'm going to have to worry about is this one right in here, 2x squared plus 3x minus 5. So when we get our complete factorization, it will look something like this. -6x times two binomials. We only have to figure out what goes in the binomials. Well, in this case, not too bad, right? 2 is our leading coefficient. -5 is our trailing constant. So let's see. Factors of 2, it's prime So that means 2 and 1 are the only two factors. And of course 5 is prime, but we have a negative sign there. So we're either going to have negative 5 and positive 1, or positive 5 and negative 1. And we need a combination that adds up to 3. Well, that's actually not too hard to figure out, right? Because if we take 2 times negative 1, then we take 5 times 1, and we add those together, it looks like we could probably get 3. So let's see what we get here in our combination. We're going to have 2x and 1x for our leading terms. And we're going to have to put 5 and negative 1 in some place so that I'm not taking 2 times 5. That would be 10, too big. So I'm going to put 5 here, and I'm going to put negative 1 here. It looks like plus 5 and negative 1. Does that work? Well, again, check the middle terms. Plus 5x for this middle term, minus 2x for those n terms. Add those together, we get plus 3x, and that is our middle term right up there. So it looks like we're pretty good. And our factorization would be 6x, negative 6x times 2x plus 5 times x minus 1. Okay, more in the next video.